Hello, in this lesson, we're going to talk about more examples on the application of logarithm, in particular, these three properties. Okay, so we're going to talk about the application of these three properties. So let's get started. These three properties plays an important role at solving equations involving logarithm. Okay, the first type of question is called expanding. Okay, expand. For example, suppose I'm picking up some homework questions, right? For example, I have log base 3 of x times y. Expanding means that we apply either the product rule or quotient rule or the power rule to separate the products or quotient. In this case, we can apply the product rule, which is going to be equals to log base 3 of x plus log base 3 of y. Okay, so that's expanding. So let's look at another example. Okay, and this one we have is ln, right? A raised to the power 3. Well, this one is not going to divide into more terms, just it's going to be using the power rule, right? The power is 3, so that equals to 3 times natural log of A. All right, let's look at number 3, example number 3. Suppose we have common log, and t to the power 5. Okay, so to expand is to write it down as log, right? T to the power of 5/5, 5/2, 5 divided by 2. And so in the end is 5/2 over log t. Okay, so that's called expanding. So let's look at another example. Example number 4, right? We have a log base 2, and then x times y, x times y, and then to the power of 10. How do we expand that? Well, this one would take 2 steps. First, we're going to apply the product rule, the power rule, right? So that's going to make us, we're going to get 10 times log base 2 xy to the power of xy only, right? So we have xy. And then we continue to apply the product rule, which we get 10, right? And we put a bracket because the whole thing is going to be expanded, and that's going to be log base 2 of x plus log base 2 of y. Okay, we still need that parentheses back or bracket, doesn't matter, same thing, mean the same thing. Let's look at number 5, right? The example number 5. We have ln square root of a times b, right? If we are to expand it, what we get is that we get ln, right? A times b raised to the power of half. Okay, and after we get that power outside, we're going to get the power outside, so 1/2 of ln ab. And then go further, we're going to apply the product rule, which is going to be half multiply ln, right? ln A times ln B. ln A times ln B. Okay, so that's called expansion. Okay, let's look at another example. It's a quotient, right? Number 6. We have log base 3 of 2x divided by y. If we are to expand it, we're going to use a quotient rule this time. So log base 3 of 2 times x minus log base 3 of y. And of course, you can expand it further. So you get log base 3 of 2 plus log base 3 of x minus log base 3 of y, right? So that's expanded. Last but not least, this one actually is very interesting. Okay, I saw it in calculus, right? Something similar. So x plus 1 over x minus 1. With x minus 1, right? So then let me make the font a bit larger so you can see it. To expand this piece, right? So let me bring the properties we need next to us so we can have a reference, right? So first, of course, we have that power, right? We have ln, and inside the radical, and we take the power of half. And the half by the power rule here, right? It will be equals to half of ln, right? X plus 1 over x minus 1. And last but not least, quotient rule, right? So 1/2 parentheses ln x plus 1 minus ln of x minus 1. Okay, be careful. Be careful. This question, okay, so let me put brackets. Just to make a distinction, okay? This question, as of here, is finished. The most you can do is that you distribute the half, right? You can distribute the half to both terms, and that's about it, okay? So 1/2 here and 1/2 there. Either one is a good answer. Either one is a good answer. Do not do this. What is that? Okay. Some people, when they get to this point, they will do the following. Okay. Some of those. Okay. From here, they will say, oh, look at that, right? We have a half. Right? And inside the bracket, I can do ln x plus ln 1 minus ln x plus ln 1. Okay, whichever version you do this. And this will be terribly wrong. This will be terribly wrong. Remember in the common mistake version, in the common mistake session, right? This will be terribly wrong. No, wrong. Okay, how is it terribly wrong? Remember, we talk about that mistake, right? The common mistake. This is the product rule. This is the product rule, okay? And if you turn product rule, if you put addition here, and that will be terribly wrong. This is right, and this is wrong. So let me make some markings here, okay? This is right. Okay, this is right. And this is wrong. We have done examples, right, in the common mistake section. And you're making exactly this mistake, okay? And this mistake comes in different versions, right? One of the version would be when base is E, okay? So this becomes ln, and this is E, so this becomes ln, and this becomes ln. So the one version of this mistake is that when you have ln A plus B, you write it down as ln A plus ln B. So this is terribly wrong. So please use it. So when you're doing, when this step, right, from here to there, and that's the mistake. Okay, so however you do it, this is wrong. Okay, just want to point it out. Just want to point it out. I remember seeing these mistakes being made by students who are taking calculus classes, right? All right, so this is the type of question that's do expansion, expanding, okay? And there's another kind of question. There's another question. This other kind of question is to make one single log, okay? Making one single log. Make one single log. Okay, so let me give you some examples. Example number 1. For example, if I have log base 2 of x plus log base 2 of y, to make a single log, right, we'll be applying these properties from right to left, okay? So the condition, of course, the condition is that they must have the same base. They must have the same base, right? They must have the same base. So here we go. We got the same base, log base 2. Oops. Log base 2 and x times y. So from 2 logarithm, in addition, we have now make it to one logarithm. This is to make one single log. So make one single log. Okay, so this is the example. So let's do a couple more. And why do we do this? This application actually has a lot of applications, has many good uses, Okay, let's take an example. We have log base 2, okay, and over here we have a half. Log base 2 of 5 minus 2 times log base 2 of 7. And if we are to write it as one single log, we have to tidy them up. We have to tidy them up so that we can apply one of these properties. Okay, product, quotient, and the power, right? So this one obviously needs us to apply the power. So we're going to bring the half, which is the power, right? The power is in front. When we bring the power inside, it will become the power. So now this is going to be log base 2 of 5 raised to the power of half. And the next one, 2 times log base 2, 7. So the 2, right? You can take a negative 2 if you want, but here I'm just going to take 2. 2 is in front of us. When we bring it to the logarithm, that becomes power. So log base 2, 7 to the power 2. And now we can apply the quotient rule. Right? The same basis, right? Same basis, A and B. And we're going to apply the quotient rule. Log base 2, quotient, and you can write square root of 5 if you want. And the denominator, of course, is 49, 7 squared. So this process is called making one single log. Okay, very, very useful, very, very useful. So let's look at some other examples. Okay, example number 3. Okay, so now we have a 2 common log x minus 3 times the common log x plus 1. Let's see how we're going to make it a make it a one single log. Make it a one single log. Power rule, right? The 2 go inside the log, becomes log x squared. Same basis, right? Minus log, we bring the 3 inside, so that becomes x plus 1, and then raised to the power 3. And then we apply quotient rule. We get log x squared over x plus 1 to the power 3. Okay, be very careful. Be very careful. Okay, not this. Okay, sometimes we see this mistake in right here. Log x squared over log x plus 1 to the power 3. Okay, these two are not the same. These two are not the same. Okay, the order of operations tell us they're not the same. So here you're going to have to do the quotient and then take the log. And in this case, you take the logarithms first and then you do the quotient. So it's a very, very different. So that's where we have lots of mistakes and confusions. So, okay. This one, example number 4. Okay, example number 4. And here we have an ln a plus b. Let me change the color, change the mode, right? ln and plus ln a minus b minus 2 times ln of c. And we want to make it as into a single log. Okay. Product rule, right? So this is going to give us ln of a plus b times a minus b. Minus, and on the second part, we're going to use power rule. So ln of c squared. And then we apply quotient rule, which will give us ln, okay, the product over here, and c squared right there. Okay, be very, very careful when you write it down correctly. This is the correct way to write it. Okay, once again, don't write it this way. Okay, don't write it this way. Some people will write it and they put this one on the top and put this one on the bottom. Terrible mistake. This will be a terrible mistake. Okay, so you make sure you use the quotient rule properly. Example number 5. Okay, example number 5. So here you have ln absolute value of x minus 1. Okay, I can totally see this in calculus work. And this equals to quotient rule, right? So ln x minus 1, that's a capital A right here, right? And x plus 1. And that's it, that's done. The only next thing you can do is that you put the absolute value into 1, okay? X minus 1 over x plus 1. That's the only thing you can do. So that's the answer, you're done. Don't do this, okay? Even though I saw these mistakes, Okay, some people would just put it like that. Very, very common mistake. Very, very common mistake. Once again, they're different, right? In this case, you do the inside first, and then you take the logarithm. And in the next case, you do the logarithm first, respectively, and then you take the quotient. So it's very, very different. Okay, you must understand. Let's look at some other examples. Let's look at some other examples. Let's work on this one. Okay, example number 6. Okay, this one we have 3 times ln x minus 4 times ln y minus 2 times ln z minus ln w. Okay. There are definitively many different ways of doing this. Here, I want to do it in a way that was more organized way to do it. Okay, certainly we need to apply the power rule. Okay, we need to apply the power rule for sure. Okay, so we're going to apply the power rule. So I have ln x raised to the power 3 minus ln y to the power 4 and minus ln z to the power 2 and minus ln w. Okay, I can go one pair at a time, right? One pair at a time, or I can go this way. Okay, I'm going to go ln x raised to the power 3, and I'm going to subtract. I look at these 3 terms. I'm going to factor out the negative sign. So I will have ln y to the power 4 plus ln z squared and plus ln w. And this way, I can do the parentheses first. So I'm going to keep the top and I'm going to do these 3 terms first. And this is the product rule, right? So y to the power 4 multiply z squared, right? And multiply w. Okay, so all these 3 terms. And then the last, I'm going to do quotient. The last, we're going to do quotient. So ln, the quotient, right? So all these 3 in the denominator, and the next one is in the numerator. I missed a W, right? I missed a W there. Okay. So when it's basically uses algebraic basics of algebraic manipulation to work on this, right? And that's how you can do it. Of course, this may be done differently, but you should get the same result. Okay. So that's about for making single logarithm. I think that's about enough example. Maybe one more. Okay, example number 7. Okay, this example is, we have a 3 ln 2 plus 2 times ln x minus half of ln of x plus 4. Okay. And we're going to make a single log. Let's see how we do that. Okay. So we have ln, so the 3 power is going to be brought inside. So that's going to be 2 to the power 3. And the second one using power rule, we're going to have ln x squared minus ln we have x plus 4, but the half power is going to go inside. So we're going to get a square root of x plus 4. Okay, so we have these, we can go by the order, right? So we first do ln, so this is a product rule, right? 2 to the power 3 is 8. So 8 times x squared minus ln of square root of x plus 4. And last but not least, the last step is going to be ln quotient rule. So 8x squared divided by the square root of x plus 4. All right, so that's the examples of making single log. Okay, so once we are able to make single log, we can do a lot more things now. Okay, so in the future lessons, we're going to cover to see what more can we do. Okay, what more can we do? All right, thank you for watching. Until next time.